Okay, and so now I believe this is going to be the last video for Chapter 5, and we're going to go back and we're going to base off of Lecture 2C, and we're going to just take another look at that, and that was me taking my car. So you got your car, and my car was going 13.4 meters per second. And then I stopped in 15 meters, and it took me 2.2 seconds to do so. Okay, so I'm going to say that, oh, and this was 1,400 kilograms. So I'm going to say that my initial kinetic energy was going to be 1,400 kilograms, 1/2 times 1,400 kilograms times 13.4 meters per second squared. So 0.5 times 1,400 times 13.4 squared is going to give me 126 kilojoules. Okay, so then when I come to the stop, how much kinetic energy am I going to have when I'm stopped? Well, when I'm stopped, my kinetic energy is going to be 0 kilojoules. Well, how did I get from 126 kilojoules to 0 kilojoules? Well, I must have done work. How much work did I do? The work that I did was 126 kilojoules. Well, work is force times distance, and so I can say that 126 kilojoules is equal to some force over 15 meters, and so that I find that that force is going to be 8.4 kilonewtons. So my force was 8.4 kilonewtons, and I believe I actually sort of went and I did that in Chapter 3, I believe, or maybe it's 4. Chapter 4, you can go back and see if I just got the same result or if I got a different result. I'll let you check up on that. And then you can also say, well, what was the power? Well, power was work divided by time. So my power was going to be 126 kilojoules divided by 2.2 seconds. So I get 57 kilowatts. Just throw in a bunch of kilos in there because I don't want to write all the zeros, and that's what it's there for. Okay, so I did basically to get from 134 meters per second, 13.4 meters per second to 0 meters per second in 15 meters and 2.2 seconds. I had to do 126 kilojoules of work, which required a force of 8.4 kilonewtons, and my power was 57 kilowatts. Okay, now I think I'm just going to throw it out here just because I've got it coming up in one of the later chapters. We're going to have this idea of momentum, and momentum is going to be mass times velocity. And so my momentum in this case was 1,400 kilograms, times a velocity of 13.4 meters per second. So my momentum was 1400 times 13.4 is 1.9, or we'll say 1.9 times 10 to the fourth kilogram meters per second. And now that's not going to have a fancy name on it, it's just going to remain as kilogram meters per second. And then an equation that we really don't talk enough about is that force is change in momentum over change in time. So if I say that my change in momentum, I went from 1.9 times 10 to the fourth kilogram meters per second squared, meters per second, and I did that in 2.2 seconds, then using that as a calculation, I'm going to come up with a force of 8.5 kilonewtons, which is not coincidentally very close to the same force that I came up using this method. So here, changing kinetic energy is the work. Work divided by time gives me force. So force times distance is work, which is changing kinetic energy. And then momentum is mass times velocity. Change in momentum divided by change in time should get me that same force. Okay, that is, I believe, all the lectures for Chapter 5.